Hello, and this is Mrs. Thomas, and we're going to talk about the animated path plot for parametric equations on the TI-Nspire CX II family. So this includes the CAS calculator as well. So what we're going to do is we're going to go ahead and add a graph page. So I'm going to hit Control Doc or Control Add a Page. We're going to add a graph. And the graph that we're going to look at today is a parametric. So I'm going to press Control Menu. I'm going to change my graph entry line to parametrics. And the equation that I'm going to first look at is going to be t squared plus 1, and y2 is going to be 2 plus t. And I'm going to go ahead and keep the standard 0 to 6.28. And I can see that I have my graph right here. It looks parabolic. And if I were to evaluate this, so about 6 squared is 36. So even in the x direction here, I'm going to go out. I'm going to go out to 45 at this point in time. And in my y direction, if I were to put in 6, yeah, this 10 is fine. So I can see that I have this beautiful graph here. And for those initial values of going from 0 to 6.28 for t, I have the full picture right here. So what's unique about the CX2 family is that when we go into trace, so menu trace, there is this option to path plot, and we are plotting a parametric. So we're going to path plot a parametric at this moment in time, and we get this play menu right here. So I'm going to go ahead and press play, and you can see that for this graph right here, that my t's are increasing. I have the points right here. I did have this equation, and I could pause this if I would like to, and I kind of do. I can reset it. I'm also going to try and hit escape here and move. I'm going to move this up to here, and I'm going to do this again. So I'm going to do menu, trace, path plot, parametric, and now I can press the play button. And we can see exactly what's going on here for this particular function. And it's going to go through the whole path from 0 to 6.28 because that is the values that I limit t in when I actually plotted this particular function of x2, y2 for my parametric. Now, some things that we always have to be aware of, we are limited in the technology, the screen. So it's not like there's a space right here. This is a continuous function. These values are going to be continuous, but we can see that it did calculate that and leave that little gap. And part of this is that step size and how things are connected. The other thing I want you to kind of look at is how this actually is going to work. So I'm going to move this play button out of the way. And this time I want you to focus on these arrows here. So if I press my right arrow, my t's will increase. And again, with parametrics, we're concerned about the path plot. So as my t's increase, we're moving up and to the right. If I have my t's decrease, I'm moving down and to the left. Now, if I hit my up arrow, I actually have this projection of where this path is going to plot. And if I hit the down arrow, that projection goes away. So there are some really nice features of just hitting path plot to see where things are at. You can also just type in numbers. So at 0, it started at 1, 2, and I can calculate that. If I press the enter, I can plot that. When t is 2, this is where we're at. When t is 3, this is where we're at. So I can get some points plotted as well based upon t being my input. And then I can always go out to that thing. Now, if I were to press in 7, it's not going to do anything for me, or 8 or 9, because that wasn't part of the domain, if you would like to call that, when we plotted our function, because when we defined this, we said that we were only looking at t's from 0 to 6.28 when we were graphing that. So let's look at another example. So for our next example, I'm going to ask you to press Doc, and we're going to insert a new problem. And this will get us to a brand new graph page. And we're going to go through the same processes. Control menu, we're going to change that graph entry to parametric. And this time we're going to do 2 cosine of t for our x, and then we're going to do 4 sine of t. For our y, I'm going to make sure that I'm in radian mode. Remember on your TI-Nspires, if you click on that, it'll automatically change you to degree, but we want to be in radian. And I don't know where my graphs went so quickly, so let's try that again. 2 cosine of t, and then we are looking at 4 sine of t. We are definitely keeping this in radian mode, and we're going to go ahead and keep it from 0 to 2 pi. I'm going to press enter, and wow, we have this beautiful ellipse right here. And again, this ellipse is going to connect right here. I could change this value right here. Let's say I changed it to 4 pi, and I now can see it's all connected. So some things that we want to just kind of keep in mind. So we're going to press our menu, we're going to do trace, and we're going to do our path plot, and we are looking at parametrics right now. And we're going to go ahead and start the animation, and we can see that we started at 2 0, and we're going up, and we're really taking this around the, if we were looking at this in a counterclockwise fashion, and it is hiding a little bit behind that value right here for t, and you can kind of see right here we're getting close to that 2 pi there. We're past 2 pi now, and you can see that we're going around a second time. So this path plot gives us our plots and our motion. So I'm going to go ahead and reset that. I'm going to start at t equals 0, and I can press that arrow to see where things are at. I can hit the up to see the projection. I could type in pi. I can type in pi halves. I can go to specific values right here. How about 3 pi halves? And see where the graph is as we're looking at that path plot. And then we can pretty much assume that 2 pi right here, we're starting over. And then because I included 4 pi as part of my domain here, I can see that I'm going around even more. So again, path plot is a really good feature to kind of help you look at the direction and be in control of your t values as you are examining different graphs. I hope this was helpful, and I hope you understand how the animated path plot works on the TI-Nspire CX II family.